I know plants release oxygen as a byproduct of photosynthesis, but what about germinating seeds? They're not quite plants yet, but they're slowly turning into plants. I've made some predictions in my head, and now I'm ready to test those predictions. In this video, you'll learn all about PASCO's wireless oxygen gas sensor so you can explore your own questions about oxygen. The wireless oxygen gas sensor comes with a charging cable, a sampling bottle, and a replaceable oxygen sensing element. Before you use the sensor for the first time, install the sensing element by removing the snout from the sensor, line up the pins and gently push the sensing element into place. Work with care around the flexible piece here. It has a tiny sensor which reports temperature, relative humidity, and absolute humidity, all of which can be reported in addition to oxygen gas if you choose. When you twist the snout back on, be gentle. It's best to just reach the beginning of a hand-tight fit. You can leave the sensing element in the unit until it's time to replace it, typically after a couple of years. The wireless oxygen gas sensor is compatible with SparkView, Capstone, and ChemView software. I've already connected this sensor in SparkView, and I have allowed it to warm up for at least 3 minutes. You can see here that oxygen gas is selected for display by default, but I'm interested in water vapor concentration too, so I'll check the box to add absolute humidity, and then I'll choose the digits and graph template to show the measurements as numeric and graph displays. Before starting an experiment, you should calibrate the sensor if the oxygen concentration in open air at room temperature is not within 1% of 20.9%. The live data bar shows 20.8%, so I can continue without calibrating. You can use the oxygen gas sensor in either an open or closed system. I'll start collecting data outside of the test chamber to get the baseline values for oxygen and water concentration in the open air. At room temperature, the concentration of oxygen gas in the air is reported as 20.9%, and the humidity is 11.4 grams per cubic meter. Next, I'll add the sensor to the bottle and seal it to measure oxygen and water concentration over a couple minutes in the closed system with germinating seeds. We'll speed through data collection for you. I'll focus on the trends once they're steady, indicating that the sensor has come to equilibrium with its new environment in the bottle. After just a couple of minutes, we can see that oxygen is decreasing and water is increasing. It's like the products and reactants of the photosynthesis reaction in reverse. I wonder if carbon dioxide gas concentration is also changing. I could add a carbon dioxide gas sensor and revise my procedure to find out. One more thing about the oxygen gas sensor. When you're not using the sensor, store it in a zip seal baggie with the excess air pushed out to get the most life out of the sensing element. Visit the experiment library at PASCO.com to find more investigations you can do with the wireless oxygen gas sensor, like testing enzyme activity. Thanks for watching.